I imagine looking into the endless darkness of space and finding something so strange and powerful that even our best scientists cannot fully explain it. Space has always fascinated me, and among billions of stars, one mystery stands out as one of the most puzzling discoveries ever. I know astronomers have spent decades with powerful telescopes, but sometimes they find signals that challenge everything we thought we understood. One such mystery started with a strange signal that traveled unimaginable distances and eventually reached Earth, leaving scientists stunned. The signal lasted only a few milliseconds, yet in that brief moment it released more energy than the sun produces in several days. These intense bursts are called fast radio bursts, or FRBs, and they are among the most mysterious phenomena we have detected. I remember the first FRB was found in 2007 when astronomers re-examined archived telescope data and saw a sudden flash of radio energy. At first, many people thought it was an error or interference from human technology, but deeper investigation showed something extraordinary. Soon after, more of these signals were discovered, each arriving suddenly and disappearing almost instantly like brief whispers across the cosmos. What amazed me most was how far away they seemed to originate, from galaxies, millions or billions of light-years distant. To still be detectable here on Earth after such distances, the source must release an unbelievable amount of energy in a very short time. That raises a question that captured my imagination and the attention of scientists worldwide. What kind of cosmic object could produce such powerful and mysterious bursts of radio energy? Some researchers think these bursts might come from highly magnetized neutron stars, called magnetars, with magnetic fields billions of times stronger than Earth's. Magnetars are already among the most extreme objects we know, capable of releasing massive energy through sudden magnetic eruptions. When their magnetic fields shift or their outer crust cracks, they can release waves of radiation that travel across the universe. That theory explains some observed signals, yet it does not answer every question we still have about FRBs. For example, some FRBs appear only once and never repeat, while others repeat again and again from the same spot. The repeating signals are especially puzzling because they suggest a long-lasting source rather than a one-time explosion. One repeating FRB discovered in 2016 sent multiple bursts over several months, surprising astronomers who were still trying to understand the first discoveries. Each time a new burst appeared, telescopes around the world pointed to the location, hoping to reveal the hidden object producing the signals. Despite these efforts, the exact source often remains invisible, hidden deep within distant galaxies beyond our reach for detailed observation. That uncertainty has inspired many creative scientific theories trying to explain the mysterious signals traveling through space. Some scientists suggest the bursts may come from collisions between neutron stars or other extremely powerful cosmic events. Others believe the bursts could be connected to black holes interacting with surrounding matter in unpredictable, energetic ways. A few imaginative thinkers have even wondered whether unknown cosmic phenomena might be responsible for what we detect. Still, serious research focuses on natural explanations, supported by evidence gathered through observation and careful analysis. With each new discovery, I see astronomers collecting more data that slowly brings us closer to understanding this cosmic puzzle. Modern radio telescopes are now designed to capture these brief bursts the moment they appear somewhere in the sky. Instruments like the CHIME telescope in Canada have dramatically increased the number of detected FRBs in recent years. Instead of a few mysterious signals, scientists now have hundreds of examples to study and compare. Each new detection gives valuable clues about the distance, energy, and possible origin of these fascinating events. Some bursts appear to come from young galaxies filled with energetic star formation and extreme astrophysical activity. Just when I thought fast radio bursts were mysterious enough, new observations revealed patterns that made them even stranger and more fascinating. I noticed some repeating bursts followed odd timing cycles, like a cosmic lighthouse flashing at unpredictable yet strangely ordered intervals. One source shocked me by producing bursts repeatedly over several years, proving the object behind the signals remained active in space. Those repeating bursts let me track their origin with much greater precision, leading to one of modern astronomy's most exciting discoveries. Using powerful radio telescopes, I traced one repeating signal back to a distant dwarf galaxy billions of light-years away. That small galaxy was full of intense star formation and energetic activity, making it a likely birthplace for unusual astrophysical phenomena. Inside that galaxy, I believed the signal came from a region of dense, stellar remnants or other energetic cosmic objects. The discovery confirmed to me that fast radio bursts were not random noise or human interference, but real cosmic signals from deep space. However, locating the galaxy created another puzzle I had not expected. The burst region also contained a persistent radio source that glowed continuously. Unlike the brief flashes I first detected, this steady radio glow suggested something powerful and long-lasting sat near the mysterious burst source. I considered the proposal that a young magnetar might be trapped inside a dense cloud of gas and magnetic energy from a massive stellar explosion. In that environment, powerful magnetic eruptions could repeatedly release enormous bursts of radio waves across the universe. While this idea fits several observations, I still debate whether magnetars alone can explain every type of fast radio burst we've found. Another surprise came when I detected a fast radio burst much closer to Earth than expected. In 2020, telescopes captured a powerful radio burst from a magnetar inside our Milky Way. This event gave the strongest evidence yet that magnetars can produce signals like the mysterious bursts from distant galaxies. For the first time, I was able to study the event in extraordinary detail because the source was relatively nearby on a cosmic scale. The magnetar released an enormous flash of radio energy, accompanied by high-energy radiation detected by multiple space observatories. This observation connected fast radio bursts to known astrophysical objects, bringing me closer to solving part of the puzzle. Yet the mystery didn't disappear, because many bursts still show characteristics magnetars alone can't easily explain. Some bursts release unusual frequency patterns that suggest extremely complex environments around their sources. These patterns change as the signals travel through cosmic gas, magnetic fields, and invisible plasma between galaxies. By carefully analyzing these distortions, I can learn surprising information about the universe's structure. In fact, fast radio bursts are becoming valuable tools for studying the hidden matter floating between galaxies. I believe that large amounts of normal matter exist in intergalactic space, but it remains extremely hard to detect directly. When FRB signals pass through this material, they slow slightly in predictable ways, letting me measure the invisible matter. Each new signal becomes more than a mystery. It becomes a scientific probe exploring the vast distances between galaxies. With hundreds of bursts detected, I'm helping build detailed maps of where these signals appear across the sky. Some bursts seem completely random, while others cluster in regions filled with young stars and energetic environments. These observations hint that multiple different processes may produce fast radio bursts across the universe. Instead of a single explanation, I now suspect that several types of cosmic objects might create these powerful signals. This possibility makes the mystery more fascinating because it suggests the universe holds unknown astrophysical mechanisms waiting to be discovered. Modern observatories are now designed to detect these signals the moment they occur anywhere in the sky. Huge arrays of radio antennas constantly scan the heavens, searching for those brief flashes. Just as we began understanding fast radio bursts better, a new discovery made the mystery deeper and more fascinating. In 2019, while studying repeating bursts, we found an extraordinary source that behaved unlike anything seen in space. Instead of appearing randomly, the signal followed a strange 16-day activity cycle that repeated with surprising consistency. For several days, the source produced regular bursts. Then it fell silent for nearly 2 weeks before the pattern repeated. This repeating cycle puzzled us because natural cosmic explosions usually do not follow such organized timing patterns. The discovery suggested something dynamic and complex might be happening near the source. One explanation was that a magnetar producing the bursts might be orbiting another massive object. As the magnetar orbited its companion, its radio bursts could be blocked or redirected by gas, magnetic fields, or stellar winds. This orbital theory could explain why bursts appear only during certain periods and then disappear. Another idea proposed that a rotating cloud of charged particles might periodically hide the signal. When that cloud turns away from our line of sight, the bursts become visible again for a short time. Such complex cosmic environments are difficult to observe directly because they exist billions of light-years away. Yet the signals themselves carry valuable clues that allow us to reconstruct what might be happening around the source. Every tiny detail within the radio waves contains information about magnetic fields, plasma density, and other invisible structures. By carefully analyzing these signals, we can essentially read the story of the environment where the burst was created. This technique turns fast radio bursts into powerful cosmic messengers traveling across the universe. However, not every burst behaves like the repeating 16-day signal. Many bursts appear only once and never repeat, which makes them extremely difficult to study. These one-time bursts may come from catastrophic cosmic events, such as powerful stellar explosions or collisions between dense objects. When two neutron stars collide, they release enormous energy that can ripple across space in many forms of radiation. Such dramatic events could produce the brief but powerful radio signals we detect with telescopes on Earth. Another possibility involves black holes interacting with nearby stars or dense clouds of matter. As matter spirals toward a black hole, intense gravitational forces can generate powerful bursts of energy. Under certain conditions, these extreme environments might produce radio flashes similar to fast radio bursts. Even with these possible explanations, we remain cautious because the universe often surprises us with unexpected discoveries. Only careful observation and repeated measurements can confirm which theories truly explain the mysterious signals. That is why modern radio observatories continuously monitor the sky day and night, searching for new bursts. Facilities, such as the Square Kilometer Array, currently under development, will dramatically increase our ability to detect faint signals. When completed, this enormous telescope network could detect thousands of fast radio bursts every year. With so many signals available for study, we hope to finally understand how these mysterious events are created. The more bursts we observe, the clearer the cosmic picture becomes. Yet each discovery often reveals new puzzles that make the mystery even more fascinating. For example, some bursts show unusual polarization patterns caused by extremely strong magnetic fields near their sources. These patterns suggest that the signals travel through environments filled with intense magnetic activity. Such environments are often associated with neutron stars, magnetars, or regions surrounding massive black holes. Each possibility points towards some of the most extreme conditions known in the universe. Studying these signals allows us to investigate physics that cannot be recreated in laboratories on Earth. The universe itself becomes a natural laboratory for understanding energy, gravity, and magnetic forces at unimaginable scales. Fast radio bursts may eventually help answer fundamental questions about how matter behaves under extreme cosmic pressure. They may even reveal unknown processes that reshape our understanding of the cosmos. Just when I thought we were beginning to understand fast radio bursts, new discoveries made the mystery even deeper. I noticed observations showing some bursts traveled through extremely strong magnetic fields, which suggests their sources are near very energetic regions. I believe these environments often involve unusual objects like neutron stars, magnetars, or areas around massive black holes. I know supermassive black holes have millions or billions of times the mass of our Sun, creating enormous gravity that shapes nearby stars and gas. I see hot gas, intense radiation, and magnetic energy around these giants, forming extremely active regions that produce powerful cosmic events. If a fast radio burst passes through such an environment, I can measure subtle changes in the radio signal. I detect changes in frequency, polarization, and timing that offer clues about where the burst originated. One signal I studied showed an unusually strong magnetic signature, indicating it likely passed through intense magnetic energy. That observation made me consider that some fast radio bursts might originate close to extremely powerful cosmic objects. I remain cautious because the universe has many energetic environments that can create unusual signals, so I focus on collecting more evidence before confirming any specific origin for these bursts. I rely on careful observation and repeated measurements to avoid incorrect conclusions about complex phenomena. One idea I find interesting is that a magnetar near a massive black hole could occasionally produce powerful radio bursts. In that case, I think the surrounding magnetic fields and plasma could influence how the signals travel. As the radio waves move through these regions, I expect they may become slightly distorted before continuing across the universe. I also consider that energetic cosmic jets might interact with nearby matter and help create powerful radio signals. These jets are streams of high-energy particles moving outward from active regions at extremely high speeds. When I study interactions between these jets and dense gas or stellar remnants, I sometimes see complex radiation patterns. While these ideas are still under investigation, they help me explore different possibilities for fast radio bursts. I know the scientific process requires testing multiple hypotheses and carefully examining the evidence. I'm grateful that modern technology is helping researchers study these signals with greater precision than ever. Advanced radio telescopes now monitor large portions of the sky continuously, searching for brief flashes of radio energy. When a burst appears, I use automated systems to quickly record detailed information about the signal's strength, direction, and structure. That data lets me analyze patterns and compare new bursts with previously detected signals. Over time, I find similarities that help identify possible types of sources responsible for the bursts. I notice some bursts are extremely energetic, while others repeat, suggesting a stable and long-lasting source. This variety tells me that more than one cosmic process may be responsible for producing fast radio bursts. I now consider that several different astrophysical events might generate these signals instead of a single explanation. Some bursts may come from young magnetars, while others might originate in energetic environments within distant galaxies. Understanding these differences will help me build a clearer picture of the phenomenon. Every newly detected burst adds another important piece to the scientific puzzle I am studying. With each discovery, I improve my understanding of the powerful processes occurring across the universe. These mysterious signals also give me valuable information about the space between galaxies. As radio waves travel across enormous distances, I observe them interacting with thin clouds of matter scattered throughout the cosmos. By analyzing how the signals change during this journey, I can measure otherwise invisible material. This technique lets me study parts of the universe that cannot be easily observed with ordinary telescopes. Even after years of research and hundreds of discoveries, I still find fast radio bursts among the most mysterious and fascinating signals in the universe. Each burst lasts only a few milliseconds, yet in that instant, it can release as much energy as our Sun produces in days. This extraordinary power makes me certain they come from some of the most extreme environments in astrophysics. Despite progress, I know many fundamental questions about fast radio bursts remain unanswered. We keep asking the same question that arose when these signals were first discovered. What cosmic engine could produce such incredibly bright flashes of radio energy across unimaginable distances? One of our most important goals is identifying the precise objects responsible for each type of burst. By studying the signals carefully, I hope we can determine whether magnetars are the main sources or just part of a larger puzzle. I expect future observatories will play a crucial role in solving this mystery. Massive radio telescope networks, now under construction, will observe the sky with sensitivity we have never had before. These instruments will detect thousands of bursts each year, vastly increasing the data we can analyze. With so many observations, I think patterns may finally emerge that reveal the true nature of these signals. We'll also be able to track bursts more precisely and identify the exact galaxies they come from. Locating their sources with greater accuracy will help us understand the environments where these events occur. I think the ultimate explanation may involve several different cosmic processes working together. The universe often produces complex phenomena that cannot be explained by a single simple theory. Fast radio bursts may therefore represent multiple astrophysical events occurring in different regions of space. Each type of burst might tell a different story about the extreme physics shaping distant galaxies. Studying these signals could reveal unknown behaviors of matter, magnetic fields, and energy under extreme conditions. Such discoveries could reshape how I understand the universe at its most powerful scales. Beyond their origin, fast radio bursts are already helping us explore the structure of the universe. As the radio waves travel, they interact with invisible matter scattered between galaxies. By measuring how the signals change, we can detect material otherwise impossible to observe directly. This allows us to map large amounts of missing matter believed to exist throughout the cosmos. In this way, a mysterious signal lasting only milliseconds becomes an important tool for understanding the universe. Every new burst detected adds another valuable clue to this growing field. Slowly and carefully, we are assembling these clues like pieces of an enormous cosmic puzzle. Some answers may arrive sooner than expected as technology improves rapidly. Other questions may take decades before we fully understand the story behind these signals, yet the search itself is one of the most exciting parts of discovery. Every unexpected observation reminds me that the universe is more complex and fascinating than I imagined. Fast radio bursts prove that, even today, space continues to surprise us with entirely new phenomena. Somewhere in distant galaxies, powerful cosmic events are happening constantly beyond our understanding. Their signals travel silently across billions of light years through the vast darkness of space. Eventually, a tiny fraction of those signals reach our planet, where sensitive telescopes quietly listen. When a burst is detected, it carries a message from the distant past of the universe. That message may have begun its journey long before human civilization existed, yet today we can capture these ancient whispers using modern technology and curiosity. Each mysterious signal connects us to events happening across unimaginable distances. They remind me how small our planet is within the enormous universe. At the same time, they show the incredible ability of human intelligence to explore mysteries beyond our world. With every new discovery, we take another step toward understanding the vast cosmic story written across the sky.